Okay, so this video is a little bit about prime numbers and what is called the sieve of Eratosthenes. So again, just to remind you, right, a prime number has only two factors, one and itself. And so what we're going to do is we're going to use this to try to find prime numbers up to 108 in this case. This goes back to ancient Greek, I think a couple hundred BC. I'm trying to remember exactly. But it's a very simple idea and it's pretty powerful. And here's what the idea is. So what we're going to do is I'm going to circle smallest. So yeah, sorry, just don't have tons of room here. So first step would be circle smallest number not crossed out. Okay, so in this case, that's going to be 2. Right? Cross out all multiples of this, of the number you just circled. Okay, so let me switch colors here. Okay, so 2. And I can think about just skip counting, right? Okay. Now this is pretty nice. I've actually set this up in a way. Right. So for 2s, actually for 2s and 3s, this actually works quite nicely. And there's nothing special about this 12 in a row, but it makes some of this stuff really nice. Okay. And again, I didn't have to stop at 108, but this is just to kind of show you. Okay, so step 2, cross out all multiples of this. Right. And then repeat until only circled and crossed out numbers are left. Okay, so we're just going to keep doing this. All right, so we'll do 3. Here, maybe I'll do circle in black. It's really clear. So 3. So 6 is already gone because it's already a multiple of 2, but there's 9 is gone. And then I'll skip count by 3, that one's gone, and then that. That one's gone. Whoops, not bad. That was this. I'm in the cross out phase. Okay, so you'll notice that it's only this column and this column that are getting crossed out. So these are all multiples of 3, and this column is all multiples of 3. Okay. All right, so far I've eliminated all multiples of 2 and all multiples of 3. So my next circled is 5, right? 5 times 10 is already gone, right? 5 times 15 is gone. 5 times, sorry, not 5 times 15, 5 times 3, right? I'm skip counting, 25. So that is a multiple of 5. That's gone. Cross that one out. So 40 should be next. 45 is gone. 50 is already gone. 55 I need to cross out. 60 is already gone. 65 I'm going to cross out. 70 is gone. 75 is gone. 80 is already gone. 85, 90, 95, 100, 105. Okay, good. And be really careful. Like the 2s and 3s, just because of the way the grid is set up, is really easy to cancel everything out. After that, they sort of, the patterns aren't as quite clear. So just be careful of everything. Okay, so 7 is my next one. And then I'm going to cross out multiples of 7. So 14, 21, 28, 35, 42, 49. Okay. And you might just notice, right, everything else up until the number squared was already canceled out because we've already crossed out multiples of everything underneath it. So skip count 56, 63, 70, 77 is gone. 84 is next. 91 should be after that. 98, 105. Okay, so we've got that. All right. So what's next? 11. Okay, this one's actually pretty nice. All the 11s are 11, 22, 33, 44, 55, 66, 77, 88, 99. Those are all gone. Okay. And again, remember, if you notice what has just happened, all those are already gone because everything less than that is a multiple of 11 and has already been crossed out. So what that means is my next one to cross out would be 11 squared, which is 121, which is below this. So that means everything else I'm just going to circle. Right. 13, because the next 13 should be 13 squared, which is gone. 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 89, oh, there we go. Okay. So the circled numbers are prime. Okay, good. All right, so this is pretty nice. Basically, all we're doing is we're just crossing out in a systematic way all multiples of sort of numbers starting at the smallest ones and going up. Basically all multiples of prime, which starting with our first prime, which is 2, crossing out all multiples of 2, then crossing out all multiples of 3, right? 4 was a multiple of 2, so we're not including that. Then we do 5s, cross out all the multiples of 5. 6 is also a multiple of 2 and 3 already, so that's gone. Then we cross out all multiples of 7, etc. Right? And so this is our list of primes. So this is pretty cool. And as I understand it, I sort of dabble in a little bit of this. This falls into number theory very much so, and a little bit of computational number theory, which means how do I actually do computing with it or computer science with it. What I understand is a lot of computer programs that search for prime numbers still use this, even though it dates back over 2,000 years. So. All right, so that's the sieve of Eratosthenes.